Here we are starting chapter 9. Chapter 9 is about solving quadratic equations. Our first section is going to be doing it with graphing, and then we're going to have a couple other methods that we use, using square roots. I can't remember what the other one is, but completing the square. A couple of other methods that we're going to use to solve a quadratic equation. But today we are starting with graphing because that's what you just spent an entire chapter doing. So the learning goal is just I will solve quadratic equations by graphing. And in order to do this, we need to remember what a quadratic equation is. So far you've been graphing quadratics, and remember that the standard form for a quadratic looks like this. Ax squared plus bx plus c. It's quadratic because our x is raised to the second power. That's the highest degree that we have here. So a quadratic equation is going to be a situation where we're going to have 0 equals ax squared plus bx plus c. So basically what we're doing when we are solving quadratic equations is we are looking for the values for x to make this whole thing equal to 0. So when we're talking about graphs then, we're looking for values of x that make y 0. So really we're looking for the x-intercepts. That's what we're doing when we are solving by graphing, is we're trying to find the x-intercepts. So what we do is we graph our equation, and wherever that graph crosses our x-axis, that's going to be our solution points. So if I had a graph that looked like this, and obviously I'm just winging it right now. If I graphed a quadratic and this is the parabola that I came up with, my solutions for this graph, or for this equation, would be x equals 0, because I cross the x-axis at 0, and x equals 1, 2, 3, 4. So I have two solutions here because my parabola crosses the x-axis in two places. If I had a different graph, where maybe my parabola looked something like this, my red graph only has one solution because I only touch the x-axis in one spot. It doesn't actually even cross. I just intersect the x-axis in one spot. So for my red graph, my solution would be x equals -3, and that would be only one solution. And then our third situation that can happen, hopefully this won't get too confusing, is I might have a parabola that is like up here. Maybe it looks something like that. Or I might have a parabola hanging out down here somewhere. In both of those situations, you can see that even as the parabola goes forever and ever in both directions, it's never going to cross the x-axis. So my green graphs then have no real solutions. So those are the three situations that you're going to encounter when you are graphing, or when you are solving a quadratic equation by graphing. So instead of me actually going through and graphing a couple of these, you, like I said, just did an entire chapter on graphing. So instead I'm just going to give you a couple hints when you do these. But remember, all you're looking for is you're looking for where your graph crosses the x-axis, or if it doesn't cross the x-axis at all, then we'd say no real solutions. So just a couple of things. First of all, if you are given your equation where it looks like this, and you're asked to solve that by graphing, you just need to graph this. Graph it any way that you want to. You know, you can use just a t-chart where you're plugging in points for x, you're finding the corresponding y values. Do whatever you need to do to graph this equation, where it would be x squared minus x minus 6 equals y. and then look for the intersection points. Once you find those points, you need to plug them back into the original equation and make sure that they work. You might also be given an equation that looks like this. So you'll see that this isn't quite set up in the same way because we have two terms on the left, one term on the right, and we're not equal to 0. So all you need to do here then would be to add 20 to each side, and you get x squared plus 9x plus 20, and now you can set that equal to 0 and you're good to go. Let me think, there's one more. Or you might have one that looks like this. Negative x squared equals 3x minus 4. So if that were your situation, what I would do is I'd add that x squared to each side, because then I'll have 0 here. And then I have a positive x squared plus 3x minus 4. So for all of these, we just want to make sure that we're equal to 0 before we graph. And then you'll be good to go. So as far as terminology goes, we talked a minute ago about how the x-intercepts, when you're looking at the graph, are the solutions. If someone says solve this quadratic equation, your x-intercepts are the solutions. So x-intercept is a possible word. You might see like solutions or what are the solutions. You might also see some terminology that are called roots. Someone might say, what are the roots of the equation? And if somebody asks you that, like just for example, this first one here, if you were to graph this, you'd see that x equals -2 and x equals 3. That's where this graph crosses the x-axis. I would say the roots of this equation are -2 and 3. That's one way that you could say that. Or another way of saying it would be the zeros. So you'd say the zeros of this function are -2 and 3. Or when you plug those into your function, you get 0. So these three terms, they don't mean exactly the same thing, but they all convey the same idea. They're all looking for when does your graph cross 0, or what does x have to be to make this equation 0. So these are the words you'll see. There's a little chart in your book about that too. Okay, for the one example I am going to do, I'm actually going to show you how to do this on your calculator, because it is sometimes just not practical to solve with graphing if you don't have a graphing calculator, or there really aren't any good ways to solve if you don't have a calculator, if you don't have the calculator handy. So I will show you how to do this on your calculator. The function h equals -16t squared plus 32t gives the height h of a soccer ball t seconds after it's kicked. So h is how high the ball is after t seconds have passed. After how many seconds is the soccer ball 15 feet above the ground? So we want to know, what does t have to be to make h 15? So really we're looking at this. That's our equation that we're looking for. We want to know, what does t have to be to make h 15? So what I'm going to do before I put this in my calculator is I am going to set this up in our ax squared plus bx plus c form so I can put it into my calculator. So to do that, I'm going to subtract 15 from each side. So I'll get 0 equals -16t squared plus 32t minus 15. And since I'm graphing this, I'm going to be looking at the graph y equals -16t squared plus 32t minus 15. So I get out my calculator. Here, let's see if I can get that without the glare. There we go. So I go to my y equals, and what I'm going to graph is -16t squared. I'm going to use x just because that's my variable. Also make sure that you're using this negative button. You're not pushing the subtraction button because it won't work. So -16x squared plus 32x minus 15. And just before I even graph it, I need to think about my window. we're probably going to be going, well, our height, let's go down to -5. Let's go 25 for our Y min, -5, because we don't really care about the ball going underground. Our Y max, we'll try 25 and see what that looks like. So that would be the ball's 25 feet in the air. So if I graph that, oops, let's do some zooming. Oh, when we subtracted that 15, that changed what our graph was going to look like. So let's change. You could tell when we graphed this that that's only like 2 seconds. So we really only need to go from -2 maybe to +3 for our x values. Let's look at that again. Okay, and then let's change and make our y max 5. Okay, so because we subtract that 15 in our equation, it shifted our graph down 15 because we're looking for when is it 15 feet, so that's why our graph's a little bit funny. So what I'm going to do is I'm going to push second calc, and we want to find the zeros. So I go to the second one, which is 0. Left bound, it's saying find the point on the left side, or pick a point on the left side of the intersection. So this is to the left of that first intersection. I push enter. Then it says right, so I need to go to the right of the intersection point, or to the 0, and then guess, and it's somewhere in the middle, and I get x equals 0.75. So after 0.75 feet, my soccer ball is 15 feet in the air, but then I need to do it again because I can see the ball goes up and it comes back down. So it's actually at 15 feet twice. So I do the same, calculate 0, but now I want to be to the left of this point and to the right of that point, and you can see my arrows up there saying your 0 is in between there. And guess, and I get x equals 1.25. So after 0.75 seconds and after 1.25 or 1 1/4 seconds, my ball is 15 feet in the air. So that's how I use my calculator to calculate zeros. Your homework for tonight is page 459, and you're going to do numbers 1 through 4, 14 through 34 even, and 41 through 50. So there's your homework assignment. Hopefully you guys are able to understand what you're doing without me having actually graphed these, because you should have a pretty good handle on that part by now. So hop to your homework.